In this chapter, we talked about circular measure. We have to understand what is arc length and sector area of a circle. This is a sector, this is the radius, this is the angle formed, and this is what we call the arc length. So the formula can be used. Arc length equals to r multiplied by theta, as you can see presented over here. Similarly, we can also learn how the area of a sector can be found. The area of the sector is denoted by this formula. If you have a sector, if there's a radius, there's an angle formed, sector area, sometimes represented by the alphabet S, is equivalent to 1/2 r squared theta. You have to understand that in this particular case, whether it is talking about the arc length or the sector area, the angle theta must be in radian, not degree. You should also understand how radian and degree can be converted into each other. Radian divided by pi equals to degree divided by 180. Of course, some of our calculator also have that functions which allows you to convert one unit into another in a quicker way. Here are some examples. If you were asked to figure out the length of an arc, which basically is the arc length, radius is 5, angle is pi/3, so arc length is equivalent to r theta, which is equivalent to 5 pi/3. As straightforward and as simple as that. In the second example, where you were asked to figure out the values of the sector area, radius is 10, so r equals to 10, angle is pi/4, so sector area is equivalent to 1/2 100, because that is 10 squared, multiplied by pi/4, and that's how you will get 12.5 pi. As I mentioned before, you must understand the formula for arc length, the formula for sector area, how do you convert degree to radian, or the other way around. Sometimes you will be asked to figure out the arc length or the sector with compound sheets. Now, in this case, let us take a look at an example. Find the perimeter of a composite sheet that includes a sector of radius 6 cm. So radius is 6, angle is pi/2, so this is 6, and then this is pi/2, along with two straight edges of length 6 cm each. So basically, you would like to figure out the perimeter of the radius, the other radius, as well as this arc length. So using the formula of the arc length, it can be found as r theta, which is 3 pi, and then the total perimeter is simply 3 pi plus the two radius. So that's the reason why you will get 3 pi plus 12. Here are some practice problems. For the first question, you would like to figure out the arc length of a circle with radius 7 cm. Angle is pi/4. Arc length formula is r theta, so it's 7 multiplied pi/4. So the answer is 7 pi/4. On the other hand, calculate the area of a sector with radius 8 cm for the second questions, and angle is pi/6. The formula is 1/2 r squared theta, so it's 1/2 64 pi/6. So 64 divided by 12 pi, 32 6, 16 3. So it's 16 pi/3. The next question, For question 3, convert 135 degrees to radian. Again, we have learned that this is all you need to do. You can use your calculator to simplify it. So the answer is going to be 3 pi over 4. This is question 3. For question 4, a sector of circle has a radius of 5 cm and area of 20. Find the angle. So for this particular sector, its radius is 5. Total area is 20. We can use the formula S equals to 1 over 2 r squared theta. 20 equals to 1 over 2 phi squared theta. That is 25 over 2, 20. Do the necessary, you'll get 40 over 25 to be theta, which can be simplified as 8 over 5 radian. The last questions, you'll like to figure out the perimeter of a shaped sector radius 4, angle is pi over 3. So not only you have to add the radius, you also should consider to include the arc length. So first of all, we need to figure out the arc length. The arc length is r theta, which is 4 pi over 3, and that is 4 pi over 3. So the total perimeter is equivalent to radius plus another radius plus arc length, which is 4 pi over 3. And the answer is going to be 8 plus 4 pi over 3. So these are the answers for these practice problems. Do not forget to work on the additional reading materials. Thank you very much.